Welcome to the session on constant acceleration formulae part 1. The objectives for this session are to derive the formulae for constant acceleration and use them in order to solve problems. Let's begin by looking at some standard notation. The following letters are used for an object moving in a straight line with constant acceleration. So S represents displacement, U the initial velocity, V the final velocity, A the acceleration, and T the time taken. Let's illustrate these. So we have an object moving in a straight line with constant acceleration. At time 0, it has initial velocity u, as shown. It moves with constant acceleration a and has final velocity after t seconds v. The displacement is s, as shown. Let's now derive some formulae using this notation. We're going to use a graph to help us. We have time on the x-axis and velocity on the y-axis. We have initial velocity u here and final velocity v here over a time t, as shown. The vertical distance shown is v minus u. We're going to use this to calculate the gradient. And of course, this is time t. The shaded area is equal to u plus v over 2 multiplied by t. We have used the area for trapezium formula to help us with this. Now, since the area underneath a velocity time graph is the displacement, we have that S equals u plus v over 2 times t. Now let's find the gradient of the line, which is of course v minus u over t, change in y over change in x. However, we know that the gradient of a velocity time graph is equal to acceleration. Therefore, acceleration a is equal to v minus u over t. We can rearrange this formula to give us v equals u plus at. So we have these two very important formulae as highlighted on the screen. We're going to use these formulae to help us with our examples. So let's begin with example 1. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at this example. We have that a tractor is travelling along a straight road. It accelerates from a velocity of 5 meters per second to a velocity of 10 meters per second in 30 seconds at a constant rate. We are required to find the distance travelled in this time and find its acceleration in 30 seconds. So let's draw a diagram to start off with to see what's going on. Suppose this is our tractor. It has initial velocity u equal to 5 meters per second. And it has a final velocity of 10 meters per second in 30 seconds. So v equals 10 meters per second and t equals 30 seconds. We are required to find in part A the distance travelled, and this of course is represented by s. And we are also required to find the acceleration in part B, and that is represented by A. Let's begin by looking at example 1a first. Let's find the distance travelled in this time. So we have the values for u, t, and v, and we are required to find the value of s. The formula, which contains all of these letters, is s equals u plus v all over 2 times t. So let's use these and input our values into this formula in order to find s. We have s equals u equals 5 plus v equals 10 over 2 times time, which is 30. And this gives us that s is equal to 225. And now for part B. We are required to find the acceleration in 30 seconds. So let's solve this. Again, let's specify which values we do have and then find the appropriate formula. So we have the values for u, t, and v and require the value of a. So we're going to use the formula v equals u plus at. Because out of the two formulae, this is the only one which contains all of these letters. So let's use this formula and plug in the values. We have initial velocity 5 plugged in as shown, final velocity v 10, and time t equal to 30. We can rearrange this to obtain a equals 1 over 6. And of course this is in meters per second squared. And now for example 2. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at this. A ball rolls in a straight line from point A to B to C with a constant deceleration of 1 meter per second squared. The velocity of the ball is 12 meters per second at A and 4 meters per second at B. The time taken for the ball to travel from A to C is 20 seconds. Find the time taken and the distance travelled from A to B. And secondly, find the velocity at C and the distance between A and C. So there's quite a lot here, and again we're going to draw a diagram in order to help us with this. So we start at point A. The ball rolls to point B and then to C, as shown here, with a constant deceleration of 1 meter per second squared. So the ball is travelling at -1 meters per second squared. The initial velocity at A is equal to 12 meters per second. At B, the velocity is 4 meters per second. We're going to call this velocity V1 because it's not quite the final velocity, but it's definitely not the initial velocity. However, at point B, it would be considered the final velocity if we're considering the distance from A to B or considering the journey from A to B. And from A to C, it takes 20 seconds, so time t equals 20. Let's focus on part A first. Find the time taken and distance travelled from A to B. So let's only focus on this part of the journey. We have the values for u, a, and v, and require t. Which formula contains all these letters? Of course, it's v equals u plus at. So therefore, let's plug in all the values. We have u equals 12 here, v equals 4 here, a equals -1 here, and of course we're trying to find time, t. So rearranging this, we have one equation and one unknown. We have that t equals 8. Now let's find the distance travelled from A to B. We have the values for u, v and t and require s. So we're going to use this formula, s equals u plus v all over 2 times t. So plugging in all the values, u equals 12 here, v equals 4 here, and time t equals 8 here, we can find s. And of course this gives us s equals 16. And we're measuring distance in meters. Now let's take a look at part B. We are required to find the velocity at C and the distance between A and C. So let's fade out the part B journey as shown in the diagram and solve. We have the values for U, A and T and require V. So of course we're going to use this formula, V equals U plus AT, as it contains all these letters and no more. And so plugging in all the values, U equals 12 here, A equals -1 here, and T equals 20 here, gives us that V equals -8. And of course this is in meters per second. The fact that V is negative tells us that the particle is moving from right to left. So the velocity v is 8 meters per second at C in the direction B to A. Now let's consider the second part of part B. We are required to find the distance between A and C. So for this part, we know that we have the values for U, V and T and require S, the distance. So of course we require this formula. S equals U plus V all over 2 times T. And therefore if we plug in the values, U equals 12 here, V equals -8 here, and T equals 20 here, we obtain that S equals 40. And of course we're measuring this in meters. This brings us to the end of this session. If you have understood its contents, you should be able to derive the formulae for constant acceleration and use them in order to solve problems. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.